Okay, so first, a brief review. Vectors. Initially, when we define a vector, we say it's displacement. From P to Q, we use this notation. Then we give it the abstract vector. Forget about the points. Vector has two components: direction, where it goes, and magnitude, also called norm or size. They all mean the same thing. Then give a line. We pick up 2 points on the line. The displacement give us a vector. Use different color. So we call this the direction of the line. Then using the dot product, we found that if two vectors zero dot product, it means they are perpendicular. A normal direction is a direction that is perpendicular to the line. So here normal. So in different contexts, this word has different meanings. In this context, I mean perpendicular. It's perpendicular to the line L. Okay, so this is the same as the perpendicular to the direction of the line. The same as the dot product is 0. Okay, so given the direction of the line, a vector is a normal vector if the dot product of this vector with the direction is 0. Then we have the following theorem. We give 2 lines. We use L for line, so L1 for the first line, L2 for the second line. The slopes, M1 for the first slope, M2 slope of the second line. Also, we can label the directions. V1, V2, normal, N1, N2. So for each line, we can find the slope the direction, a normal vector. We can also find the slope for second line, direction of second line, normal vector of second line. The connection between them two lines are perpendicular. L1 and L2, they're perpendicular. This is the same as two directions. Dot product is 0. Same as normal vectors. They're equivalent. And lastly, these four statements are equivalent. When two lines are perpendicular, the two directions also perpendicular. Two normal vectors perpendicular. The slopes of the lines, we take a product, we get -1. So this, we will see this several times. At other places, how do we prove this? We have to use the dot product. Two vectors are perpendicular if and only if the dot product is 0. So not only we know the statement, but we also know why. Okay, then a useful method to find the normal vector given okay, let's recall how we did this.
Wait, teacher, real quick, why is M1, M2 -1 again?
Yes. So this is a long proof. We will go over the proof shortly. That's a very good question. Why? It's not obvious. We have to do some steps to get to there. In order to get here, we need to find a way. If we have a vector here, that's a good question. Well, we will answer this shortly. How do we find a normal vector?
Can you scroll up a little?
Give me 1 second. Well, I want to make this perpendicular. Okay, look us further up,
Thank you.
just here. Okay, Amy, if we have a vector v with two components, do you remember the formula for the normal vector?
Um,
Not exactly, but I know that if you want like the slope to be perpendicular, it's like the negative reciprocal.
Okay, okay. So if we want two lines to be the perpendicular, their slope is negative reciprocal.
Yeah.
Okay. So to find y,
Wait, so is that why M1, M2 is -1?
yes.
Oh, okay.
So slope m1, slope m2, two lines perpendicular, the product is -1, that's a negative reciprocal. Okay, maybe a different way to see this is same as negative reciprocal.
Wait, what does reciprocal mean again?
Reciprocal r to 1 over r, the reciprocal.
Okay.
So this is the reciprocal, a negative sign, so negative reciprocal. That's what Amy used, so I took it. Lucas, turn on the camera. And George,
So that's why e equals to -1?
that's not why. It is, but why we are going to answer why.
Okay.
Isn't that the thing like pre-calculus where the limit for the limitations on like all
No, 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 no. We're not there. We're not there. So it's not needed.
but that's why
Okay.
it's -1, right?
Okay, so George, two vectors are perpendicular.
Yes.
Any condition that can guarantee they are perpendicular. When are they perpendicular? Using our theories.
If
When
they're
are two
perpendicular,
vectors?
they make a 90-degree angle. If they make a 90-degree angle, the vectors are theoretically opposite.
Okay, okay. This is technically correct, but not what I wanted. I want to say two vectors are perpendicular.
When the two
If an
slopes times when the two slopes of the lines are times and they equal to -1.
okay, Lucas, turn on the camera.
Wait, what did he say? I did not hear him.
So he said it's something we wanted to prove. He said it's correct, but we don't know why.
Oh.
Not yet.
Oh,
The
okay, 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 not
like
yet.
multiplication of the two slopes is -1.
Okay, so two vectors, they're perpendicular, even only if their dot product is 0. So here, give a vector v to find a normal vector when you do the dot product is 0. So I'm going to pick negative b and a. Okay, I will give you a minute to verify the dot product of these two vectors is always 0. Okay, verify. No matter what the first vector is, I switch the positions, change the sign of the first one, we get a normal vector. Jessica, do you know how to verify this?
What?
Yeah. Wait, could I say it?
Okay, Amy, why? How do you
'Cause
verify
like
this?
if you use like the dot product, it's just negative BA plus BA, which is 0. So who's Zisha? Sorry, I did just someone in here that I didn't see before. So
Okay, yeah. So Zisheng is a student from my another class.
okay, okay.
Okay,
I
you
see.
have quite a few from a different class. George, Zisheng, and Lucas. Okay, let's check the three examples. First, if my V is 1, 2, can you find me a normal vector? Okay, I will start with Amy. Okay, you go first.
-2 and 1.
-1. Jessica, can you find me a normal vector of V2?
Wait, 0, 3.
0, 3. Okay, we can check the dot product of 2 is 0. Another one. Okay. I'm going to ask Kira, the vector V, can you give me a normal vector for this one?
2, well, no. Wait, -1, 2.
Okay, so what we did, we switch and change one sign, not both.
Oh,
If I
it's -2. Whoops. -1, -2.
-1, -2, yes, because we are so used to positive numbers. Sometimes if we go to negative numbers, get the incorrect ones. Okay, so
What's the rule
here
for
again,
multiplying the vectors again?
George, what's the question?
What's the rule for multiplying vectors again?
Okay, so here we only have the dot product.
Oh,
So
dot product
and
is just. I just
okay,
getting this.
do you remember the formula? How do we do dot product, George?
X1 times Y2, no, X1 times X2 times negative Y1 times Y2.
No, it's the x1, x2, y1, y2, then we add them.
Oh,
The
and I
summation of the product. Okay. Now let's go to the theorem. We have two directions. They are perpendicular. Suppose they are perpendicular. It's the same as in this question, we assume both slope exists. For this one, the slope will be B1 over A1. This one, the slope will be because the second component tell us the change of the y coordinate. This is the change of the x coordinate. So the ratio change of y coordinates over change of x coordinates give us the slope of the line. Similarly for this one, change of y coordinates, change of x coordinates give us the slope of the line. Okay, now let's continue. Lucas, these two vectors, the dot product is 0. What does it mean?
It means it's perpendicular.
Formula. Give me a formula using the coordinates.
coordinates.
A1, A2, B1.
I kind of forgot how to do dot product.
Hey, teacher, I think if you want to flip something to make it perpendicular, you flip it by 90 degrees. Or if I think we said 270 degrees, and then it would be negative y, x. So it's if you have a negative value, sorry,
It
have a
would
negative value divided by negative. Okay, I forgot how to do this.
I know what it is. I understand it now.
Okay, Lucas.
Wait. Just random two coordinates of v and n. V1, V2. You could say uh any of them. Wait, could I set a random integer for each one?
No, just use A1, B1, A2, B2.
So it would be V1 V1 times V1 times V1 minus V1 times V1 minus V2 times V2. I forgot.
Okay, so when we do dot product, I can copy the vector
Oh, it's plus. Wait, never mind, it's plus.
A1, B1 dot A2, B2.
It would
This
be
is okay. So at this step, I'm going to divide both sides by A1 and A2, or multiply the reciprocal. If I multiply the first term by this, I get 1. Multiply the second term by the reciprocal, we get
wait, why is 1 over A1 A2 equal to 1?
no, it's not equal to 1.
Well,
This just means that A1, A2 equals A1, A2 is like the opposite of B1, B2 because one has to be the negative value of the other one.
oh, okay.
Okay. So from this equation, I divide both sides by A1, A2. So A1, A2 divided by A1, A2, we get 1. B1, B2 divided by A1, A2, we get B1, B2, A1, A2. 0 divided by this is still 0. Okay, you can compare these two formulas. First formula from dot product. Second formula from division.
Dot product is just normal multiplication.
Okay, we have studied that many times. I'm going to skip that. So
Wait,
now see the connection between the two equations.
dot product and division between vectors is just kind of like normal division between.
No. They are not related. So dot product is dot product. Division is division. They're not related. They're two different steps. Do not mix them, George.
This is normal. This is confusing because I'm not really getting this.
Okay, so the dot product, they're perpendicular. The dot product is 0. We get this equation, then we multiply both by the reciprocal. First one become 1, second term become this. Now we recognize this is our M1. This is our M2. So from there, we conclude 1 plus M1, M2 is 0. M1, M2 is negative 1. Okay, M1. That's how we go from two vectors being perpendicular to the slopes and negative reciprocal.
Okay.
Okay,
Because
so
we proved that B1 and A1, B1 is the same thing, right?
so this is the slope.
Yeah.
Slope is the ratio of the two components. the slope.
So
So
we
now we
proved
can
it. A1.
B1, A1, we have the first slope. B2, A2, the second slope.
So we proved that one slope is a reciprocal of another.
It's the negative reciprocal.
Negative reciprocal. Yes.
Mhm. So y is all comes from here. The two vectors are perpendicular.
Oh, I get it because like if you flip it, the one of the values is negative. Yeah,
Mhm.
I get it.
Okay. So this is about the proof of the theorem. Next, we learn equation of circles.
Wait, can you scroll up a little bit?
Okay. This is a simple example. This is how we define dot product. Okay. We start
You kind of
with,
get so you kind of get the slope the same way you do with vectors as with like coordinates.
so they are related. For example, if we have a vector with component A, B, then the slope of this vector will be
It's A over B, B over A.
B over A, yes.
Yeah. Yeah.
Circles, so we have
What be that?
center, radius. Okay, so we have a point on the plane. We want to consider set of points with distance. All the points where the distance is r to q to p, we get easy remove the point. And any point over there. Okay, so this is a circle. All the points with the distance to the center equals the radius, we give a circle. This is the formula, the geometric definition. Okay, so P has coordinates A, B. Q has coordinates X, Y. Okay. Aaron, P,
Yeah.
Q. Okay, camera, turn on camera.
My camera turned on for like 2 seconds and then glitched.
All right,
My
okay.
camera just hates me. Technology hates me. I mean, I would understand why it does, but
Okay, Aaron, we have 2 points, P and Q. What is the displacement vector? from P to Q.
Let me see now. Wait, isn't this just R? Displacement?
So R is the length, not the vector.
This
Oh,
Vector, two components.
hold up. Hold on. Displacement? I kind of forgot what that meant. I forgot.
Uh-huh.
I kind of forgot.
Okay.
Oh, is it like I got this. X minus A and Y minus B?
Okay, yes, the changes of the coordinates. Yes.
It's like almost like an absolute value thing, but like
It will come to the norm of this vector.
mm-hmm.
Let me check with Zisheng. Are you on a car at home?
I'm at home.
Okay, turn the camera, you're at home. Okay, Zisheng, what's the norm of this vector? Magnitude. Zisheng?
I'm not sure.
So we have a vector here. How do we find the norm?
Uh,
I can hear this keyboard typing.
I think you
Um,
Zisheng, we can hear your keyboard.
What's the background, bro? What is that background?
Don't
it's
Okay,
something called a blur.
ask questions. Just don't ask questions.
okay. Amy,
Wait, just quick question, teacher.
okay.
Why
Huh?
can't we use a, you know what, never mind.
Okay, Amy, what's the norm of this vector?
To find the norm, I think you do like the square root of the x squared plus a squared, and then minus a squared, and then okay, plus the square of y minus b.
Okay, so this equals R. Then we take a square of both sides,
Wait,
we
it works.
get,
Wait, my camera works. Hold on, it works. Oh, yeah, it works.
okay, perfect. Okay, so this is equation of circle. So from this equation, we can write the center with A and B. Keep in mind, it's a difference because it's the displacement.
Wait,
This difference.
why does x minus a squared plus y minus b squared equals r? Isn't that like the norm?
Yes, that
So,
was what I'm asking.
So the
oh,
norm,
we're trying to
that's a
prove that?
definition of a norm.
We're trying to prove why is that?
No, we already know that the norm of something, by definition, is x minus a squared plus the square root of x, a2 minus
No,
a1.
why does it equal r?
Okay,
R
so
in this
this is
case
the geometric description of the circle. The
Wait,
distance
hold on.
equals the radius.
How did
Isn't
we how did we get
the norm
displacement?
equals like something about root a plus b squared? I mean a squared plus b squared and then root that.
Okay, so that's with for a different part. It's not for circles.
Oh. Aha.
How do we get displacements again? I just keep on forgetting.
Change. So displacement. From A P to Q. From P to Q, first coordinate change from A to X. The difference is the change in the first coordinate. B to Y, the difference changes the second coordinate. The difference. This gives us the displacement.
So what would be the displacement in this case?
It's this.
I thought that was the vector. Oh, is that the
Displacement is a
displacement?
vector.
That's a displacement vector, right?
Mm-hmm.
Okay, that makes sense.
Okay. So now let's
Complicated.
consider some examples. First one, center at 3, 4. Radius is 5. Give me the equation of this circle. Okay, maybe enter your answer in the chat when you are done. What is the equation of a circle?
Oh, I can't type in the chat.
It got
Why?
disabled
I think the chat got blocked because we were
because they
talking
were
about
chatting
what
too
else is there.
much.
Okay,
That was
they were
not
chatting
nice.
too much.
Bro, this kid named George was really typing trash, bro, I swear.
I don't know. I'm just trying to spell the word autism without getting banned.
Oh my god.
But you can send chat to me, right?
No,
Yes, I can.
I can't. Wait, actually,
You
Okay,
Yeah.
send chat to me.
yeah.
Uh,
Oh, wait, what do you mean by equation of the circle?
Something like this. Center and radius.
Okay. Sure.
Okay, have 2 responses. Okay, Zishan, we use square. Okay, maybe you don't know how to input a square.
You use
Square,
shift 6
square.
and the number. That's square.
Okay, area is
Bro,
correct.
my computer does not have that ability to do square.
You can
Okay,
just do
okay.
shift
Okay.
6
Do you
to.
do you
Right,
just
I
use
did-
X and Y for X and Y?
No,
We
it's
use X and Y for X and Y. Yeah.
yeah.
I wonder why you asked.
Wait,
Also,
couldn't you?
Zishan should be the displacement, should be the difference.
Oh my.
Displacement vector, bro. Displacement vector.
Amy,
Bro.
our center is 3, 4, not 0.34.
Hold on. So isn't it just basically x math 3 squared plus y math 4?
Don't tell them the answer, you dumbass.
Yo,
Okay, George, stop,
chillax, bro.
I'm going to
Like-
throw a pig at you, I swear.
Bro, that's
Okay.
because why is he blocked the chat, bro?
See this? I'm gonna throw it at you.
Okay,
Good luck.
so you can see in this equation, we can read the center directly 3, 4. This gives us the center. 5 squared, 5 is the radius.
Is it okay if we just said 25?
It's okay. It's okay.
Yeah,
But
I was like too lazy
yeah.
typing.
Center negative 3, 4. Radius 2. Okay, equation of this circle. Again, enter the answer in the chat. Okay, I have 1. Okay, double check. Kira, you have A over there. What's A?
Wait, I wanna ask, how did they do it so quick?
Well,
I think they
practice.
pre-checked.
No, it's me doing it too slowly. That was the previous one.
Oh, okay, I
Oh.
see.
Oh.
Okay,
I thought I'm the fastest.
Bro, this is
okay, correct, Amy.
Am I right?
Aaron, correct.
does that say 2? Yeah, that says 2.
That does do.
Bro, wait, can I just expand on that, say x squared plus 6x plus 9 or something? Could I?
You don't
We could, and we will.
Ah, George.
What? Child, you don't want math to get more complicated than it already.
Bro, this is simple quadratics.
Wait, I have a
I
question.
hate simple
Yes,
quadratics.
Amy.
One
But
thing
it's
about me.
George,
unrelated.
stop.
It's unrelated to math.
Okay.
How old is George?
Very young.
He's
I'm
like
14.
he's like
I'm
10 or
minor.
something.
I'm 14. I'm a minor still.
What? Okay, chat, that's
Teachers
cap.
know.
That's cap. You literally
I was
talked-
子正. I'm like,
I'm sorry. I'm sorry. I thought he was like 11 or something.
I'm not. My brother's 11.
George, you see?
George,
Okay,
you sound like 11-year-old.
okay, Aaron,
You are
okay,
an
that's
11
enough.
year old.
Nope, I'm actually 13.
Yeah.
Okay, so given the center and the radius, we can find the equation of the circle. Okay, yes. So here we have plus because it's minus -3. So be very careful. Have a plus is minus -3. Okay.
Which is just 3.
Okay.
Wait, teacher,
Next,
am I
I'm going
right?
to give you this. X.
Teacher, am I right?
Yes. But it should not equal plus.
Oh, plus.
Mhm.
Oh, my bad.
I mean, it's
No, I
negative
pressed the
3.
thing. I pressed like the plus button. It just didn't register. My bad.
Your plus button just quit, bro.
Wait, Mr. What's your Peng Fei?
Mr.
Uh-huh.
Kobe.
Do you know the shortcut to typing like superscript for like the square
So
part?
we just use this.
Yeah, I don't like superscripts.
Yeah, but I can't draw.
No, do not draw. So there is an upper of 6, I think.
Yes?
So
It is the shift of 6, yes.
okay.
Yeah. Oh,
Shift 6 is this then.
I see.
I always
Okay.
think it's something stupid and then
Previously, we have the center and the radius. We find the equation of the circles. Now we have an equation. Enter the center and the radius for this circle.
Wait, so if we type that in like decimals, I can get a circle?
Center and radius.
Yeah, I'm gonna try. Beautiful free math.
Okay, we have a new equation here. I claim, again, this is the circle. It's a circle, so what is the center? Radius, center, okay, correct. Radius, okay, yes. I have 2 responses for the third one.
Wait, what? Hold on. I'm kind
So
of
we
confused.
go backward,
Wait, teacher,
forward, find the equation. Backward, find the center and the radius. Yes, George.
I tried to graph that and it didn't get
No,
it.
okay. No graphing then. Just
Oh,
find the center and radius.
come on. Center and radius. Damn it.
Uh,
The radius is 3, I can tell you.
okay, that's great. I have 1. I'm sorry.
What?
That's great. It's 3.
And their center is 2, 3.
Okay, so
No,
George
no, no.
says.
-3, -2, -3.
Okay. So this is the trap. Whenever you see plus, you should be careful because we expect the difference. So now you see, be careful. This is a practice. -2, -3.
Yes.
Okay. Next one, we go even further.
What is it?
X squared, y squared
Hmm?
minus plus 2 squared, 2x.
Oh, we're just factorizing like
Oh, yeah.
quadratics, yeah.
Well, but then what's the actual number?
Our like slow brain school is just learning about
Okay, George,
Oh.
stop that.
Wait, isn't it supposed to be a number? Unless I'm
Oh, I get it. I get how this works.
I see.
I see.
Okay, again, I claim this is a circle. Can you tell me what the center is, what the radius is? We have 5 minutes break. We continue at 21.
Yeah, I think I got it. The center is 2, -2.
Okay, enter in the chat.
Oh, my bad. I did it in like
Wait,
1
is
minute.
it 2 and -3?
No.
That's just wrong. I made
What
this.
is this
You're just wrong.
factorization?
You're
So
incorrect. I made
what we
mistakes.
do, we need to complete the square of x.
Yeah, so that's basically just x plus 1 squared, and then let me think. It's
Okay, see, Aaron mentioned we add 1 on both sides.
yeah,
Then y squared minus 4y. How do we
that's
complete this
basically y
square?
minus 2 squared, but
So we
then plus
add
4.
4.
Yeah, plus 4. So that basically just means x plus 1 squared. Oh, I know where I got it wrong now. I forgot to
Okay,
put the squared
okay.
around it. So it's just y minus 2 squared,
How
and
is
then
this completing square? I don't get it.
It's
So
that's not how I would.
initially we have this. Now we have a complete square, George.
Oh, well,
Oh.
wait, so can I
So
just say radius is root 5?
yes. So from there we conclude the radius
And it's
is
negative 1 too.
okay. Yes, center will
How
be
do I
negative
know what to
1.
add? Like to complete the square. How do I know what to add?
Okay, that's a question. Okay, let's try
I
to
just don't
answer
get
George's
completing the square.
question. Okay, George, stop. Let me give you the formula. X squared plus ax. How do we make this complete square?
Plus B.
So we want to find something. This will be whatever a is, you add a squared over 4, subtract a squared over 4. And this is x.
Sorry. I hate allergies, by the way.
Okay,
Oh, I did not remember this. Like
Wait, have you
okay,
learned factorization in school?
my school
okay,
teaches
okay,
nothing.
okay. Aaron and George, no chatting. No chatting. Okay, one more example, we'll move on. Number 6.
Wait, why did you just go to never mind.
X
Wait, I have
squared.
a question.
Yes.
So like I think in the standard formula for equations like this, wouldn't there be like additional like plus 6 after the for y or something? Like it's basically just something about x squared plus y squared plus let's see, ax plus by plus c, I think.
Plus ax plus by is 0. Okay, the general case.
Oh,
Give me the center and the radius for this circle.
okay.
This is pretty stressful.
Okay, we need complete square. X squared ax. Y squared by.
I
Mhm.
got it.
Okay, what's the answer?
So I think the center is negative A and negative B, right?
Almost. Small corrections.
Wait, I think we can see from the previous questions and we can think about it. We can think about our mistakes
Okay,
and we can improve.
Amy, so there's a factor 2 over there. Why? Because there's no, if we have 2a, then there
Oh,
will
okay.
be, yes.
Negative A over 2
Mm-hmm.
and negative B over 2.
Okay. Okay. This also change the radius. What's the radius?
Is it like the square root of
It's like
A over 2 squared plus B over 2 squared?
Yes.
yeah, that's what I got too. Wait, I think I typed it to you.
What did you got? Oh,
I got like something like the center equals negative A over 2 and negative B over 2.
I
And then
guess, bro.
Okay. Okay. Yes. Yes. That's correct, Aaron.
good. Wait,
We
so
can
this is
simplify this
basically
a little
factorization.
bit. We get a square b square over 4 square root, which is
Wait, that's over 2.
It's over 2,
Yes.
teacher.
It doesn't look like a 2,
I
huh?
don't think it's how it works.
So
over.
square of 2
Oh,
is
yeah.
square of 2 is 4.
Yeah, I think, yeah, I get it.
Okay. Okay, now we can see when whatever A is, whatever B is, this give you a circle. You can find the radius and the center. Okay. Next, we move to complex numbers, the one you have learned before, but now from a different perspective.
I've Googled things before, and like I think complex number I has to do with displacement.
Okay, complex, no, not really, complex numbers. Okay, let's start with Jessica. What is a complex number?
A non-whole number? I don't know.
So a complex number has 2 parts.
Wait, can I say them?
Okay, yes, Amy.
I think it's like A plus BI.
Okay, that works.
Oh, I have an idea.
It's got the real part and the non-real part.
Yeah.
Okay.
Real
part
and
and the
imaginary
imaginary
parts,
I
part.
have a better version. Okay, so Z equals X plus sorry for that noise.
Why?
X plus YB. I mean YI, sorry, YI.
Okay.
I prefer them.
I
Okay,
was distracted by the noise. Sorry.
that also works. Okay, either A or X, this are called the real part.
Wait, so I is like the root of -1. Check.
The real part of Z. B or Y, the imaginary part. So here, both A, B, X, Y, they are real numbers. For example, if I write 2 plus 3i, okay, what's the real part of this complex number?
2.
Real part, we have one candidate. Imaginary part,
The email address.
yes, it's 2 though.
Hmm.
Isn't
Isn't
okay,
2 the
Aaron,
real part?
is this the real part too?
Oh.
What's the imaginary part?
Wait, are we gonna get to the Euler thing today or no?
Yes, we will.
Why
yeah.
are you asking? Euro is like a children torturer.
Hey, let's not call him that.
He tortures
Okay,
children.
no chatting. Okay, no chatting. George, no chat.
Hold on, isn't Euler like something about like E equals cosine plus sine times the
Okay,
I?
something like that.
Euler's just like the father of
So here,
trigonometry.
be very careful. The real part, not 2.
It's like 3i times I, because that's basically just 3 times negative root 1.
Because if we check 3i squared, George, what is 3i squared?
3 squared is -3.
Yeah,
So this is basically -1.
I believe that's true.
So the real part, not a 2, but -1. What's the imaginary part?
Well, then it has to be 2. But there's probably no imaginary part, so yeah, there's no imaginary part.
Okay. Even though we have 2 plus something I, because this part is not a real number. So this is not the imaginary part.
What?
So when we say the real part, imaginary part, both parts must be real. So here is not
That thing is actually not that is not a complex number?
not 3i but 0.
Okay, that's weird.
Okay. Then for real numbers, we have the absolute value. For vectors, we have the magnitude. For complex numbers, we introduce the modulus, absolute value.
Doesn't that equal R according to my sheet?
Okay, there will be, but step by step. So this is called the magnitude. And this called the modulus.
Aren't they basically the same thing but in different form?
Okay.
Wait, aren't they all like the same meaning but like different form?
In different contexts,
I
when we
guess.
say modulus, it's about complex numbers. When we say magnitude, it's
It's like
about
Wait,
vectors.
is modulus just all all complex numbers?
No, so the norm of a complex number, we call it the modulus.
What?
I think he's explaining it.
Normally, we use the short notation R for the modulus. If I draw the coordinate plane, we have a complex number x, y,
That's a circle. That function's a circle, I think.
0.
Wait, teacher, can we inference that V is... Oh, no, never mind.
Okay, so what is this complex number?
You mean the point or the line?
Yeah.
The complex number z equals to,
Oh, Z.
V equals to 2 plus...
That's root 5.
so has the real part and imaginary part.
Oh, it's supposed to be x squared plus y squared equals r.
Wait, so that's basically just
2
2
plus
squared
1.
plus 1 squared.
Okay,
Right.
2
Yeah.
plus, oh wait, 1 plus 2i, sorry, wrong
Oh,
way.
Yeah, that
yeah,
makes sense now.
because it's
Okay,
x, y, yeah.
Yeah.
1 plus 2i. Then the modulus,
Because 1i would be pointless.
The modulus would be like
Plus would be like 1 squared plus 2 squared, which is
root 5.
square root of 5.
Oh, you could just say root 5, but I guess that works like that.
I'm not used to saying that. Root 5.
okay. So now you can see the connection between a complex number and its modulus. It's like the magnitude, like the norm, but we call it modulus. So we know when you hear modulus, okay, we are talking about complex numbers. When you hear magnitude, we're talking about vectors. When you say absolute value, we're talking about real numbers. Okay, so we have the magnitude. We have another geometric object, this angle.
Modulus?
Okay, so we call this the argument. Okay, now let's consider the general case.
Wait, so then we can use the vector so we can calculate. We know the y is 2, and with the vector we can calculate the r. No, we can just use 2 and 1 to get the r. So that is root 5, and then we can use that to get theta.
Okay, yes.
Wait,
We
let
will,
me try.
okay.
Root
We
5.
will consider a general case. A general case, we give the argument, also give the modulus. Can you find this complex number using the modulus and the argument?
Wait,
Yes.
teacher, if r is root 5 and then you use root 5 to divide it by 2, you will get a number that is bigger than 1. So there will be no real values for theta.
Okay, so forget about this one. We move to the general case.
Okay.
Hold on, that looks like
So,
an acute angle.
Acute angle.
Say
Z equals x plus yi.
well, yes, I think
Yeah.
that's the general formula. Hold on. X
okay,
if
so
I
to find this complex number, we need to find the real part. What's the real part?
the real part
The
is
real part
probably
is
the x value.
x.
We have a right triangle over there. This hypotenuse is r. Angle theta. What is this?
Wait, I think
That would be
like
cosine.
That's
I think
basically just hold on.
the face of the triangle is real.
You said that complex numbers are complex.
The real part.
I think the real part is like the base of the triangle.
No, that's like x over r or something.
No, the real part is the x. So the real part is the base of the triangle, not you think. It is.
Technically, yes.
What's the imaginary part?
That's the y of the triangle.
The y of the triangle and the hypotenuse.
Yeah. What?
Wait, hypotenuse?
I think a hypotenuse is a complex number.
The
What's the
hypotenuse
formula?
is already part of the real part because it says r times cosine.
No, because the hypotenuse is r, which is
Okay,
x squared
drive
plus y
stop.
squared. It's a real number.
Exactly, I think.
Okay, what's the imaginary part? We found the real part. Now we found the imaginary part. The imaginary part will be this side to be r sine theta. Okay, so we found the real part and imaginary part. Put them together, we can assemble this complex number.
Why would r cosine theta get you x?
Because in this right triangle, this is the x coordinate.
Yeah, which is the cosine is just x, right?
Cosine. Okay, so we call this the
Oh yeah.
polar form. Let's compare the two formulas.
What? Oh. Wait, they don't they equal each other, I think?
Yes, just two presentations.
Oh, I see.
So we call this the rectangular form. This the polar form. Okay, so two ways to present a complex number.
Wasn't the polar front like the wind in science class?
Okay, so this
That's
will
not like science right now.
That's not what we're talking about at all.
I don't even know who's talking right now.
In case you haven't noticed, this is not science class.
I did
okay.
not.
Well, let's not go that far. They are related, but not that direct.
Oh, that's cool.
Okay. The polar form. This Euler formula.
Isn't this a
in-
thing that like spins around in like a cylinder thingy in like a 3D shape?
No. So this Euler formula is that EI theta.
Yeah.
And no, oh, and yeah, that one.
Cosine plus I sine, I think. And then there's something called the power series.
Okay, so we should be very careful about this formula.
Isn't this log though?
So
Because it's the
before,
base.
whenever we see exponential function, we only about integers. Sometimes we allow fractions. This is the first time we allow imaginary numbers.
Wait, is this pre-calc already?
Not yet.
This looks like something I learned next year or something.
Okay.
Wait, I
The
have
last
an
lecture is probably just
interesting-
like how to feed babies.
Okay,
Oh,
Amy.
I just wanted to say something about how calculus was invented.
Okay. Mhm.
Right to me.
Oh,
I have an idea.
Okay.
yeah.
Okay, Amy, continue.
It was basically Newton was like trying to solve this really ridiculous problem, and he literally invented a whole new branch of math in the process of trying to solve the problem. So yeah,
Okay.
say that.
How
Uh-huh.
pre-calculus invented?
No,
Okay.
pre-calculus is just like a curriculum. It's like it's
Oh.
like preparing you for calculus. It's just calculus.
So
The
pre-calculus
introduction
is a very recent thing. Maybe 20 years ago, there's no pre-calculus. It's a very recent thing. Allow imaginary. Okay, we should be very careful about this formula.
Is it the only time we allow
Wait, no. Is it
imaginary-
like the first time you allow like I in a exponent? Is that what
Uh-huh.
you mean?
I want to ask, is it the only time we can do this?
Wait, so if you like a time like have an I for an exponent, what's the result?
Okay, so let's check a few results cases. First, if theta is 0,
What does E stand for in this case?
E I 0.
Yo, who was
Okay,
whispering, bro?
let's find E I 0 using the formula.
Theta is a straight line.
Okay, use the formula E I 0.
Then that's just
I
basically
think,
one.
yeah, that's just a straight line.
Yeah.
1
Because
plus,
one.
okay, maybe one more step.
Oh
Let's
wait.
go cosine 0, I sine 0. Okay, we know cosine 0 is 1.
Oh wait, then it's square
That's
root
just
of
0.
one.
That's I is 0.
I times
Okay,
0 is 1. Sine
so
0 is 0.
Yeah.
next
Like
one.
literally anything times 0 is 0 to yeah, that makes sense.
Theta is pi over 2. Let's find EI pi over 2.
Oh, wait, what?
Yeah, power of 2 is
Wait, that's just basically
cosine 2. Wait, what?
no cosine 2 plus I sine
I sine 2.
yeah. Wait, hold on. This is
Wait, wait,
pi
what do you
over
mean
2.
by theta
That's
is
90 degrees. That's 90 degrees.
why is 2 90 degrees though? Oh, pi divided by 2. Yeah, 90 degrees. So that's 1 and 0.
Well, actually it's 0 and 1 actually.
I was saying sine first, but yeah. So
Wait,
so then it would be
that's I.
I. That's just I. How would you
Okay,
Wait, hold on. Can I
so
take
this
a
is
few moments to write this down? I forgot to write
Okay.
it down. Hold on.
Teacher, how
Very
would you
interesting formula. EI pi over 2, we get this I.
teacher, I have two questions.
Yes.
First of all, why does this even work? And how did Euler even think of this? Second of all, how would I graph this?
Well, so to verify this formula, you need to study a lot of mathematics. You can only verify this after you go to college, you learn calculus.
Okay, it's fine. We can skip that. How would you graph it then?
That's a very tricky thing, I
I
think.
think, do we need to use like graphs as like
Hold on.
binary components like xi, yi?
Okay, so George, if you want a graph, this is kind of the graph. Let me
Wait, so
I recreate.
I
wait,
mean, how would
Okay,
you
can
draw I?
I share
How would you
something?
draw it?
Yes.
Okay. So this reminds me of like the you know those algorithms and like arithmetics? This is like the our arithmetic. Like this looks just like it. Uh hold on, what? Yeah.
I recreated the picture. Instead of Z, I write R E I theta.
Oh, that's
That's kinda smart, but where's this
I
So
I could have wait. I would love to wait like 6 more years before I learn about this.
wait,
okay,
where's the Z?
so Z is this complex number.
Wait, teacher, can I draw something real quick? I want to ask you a question.
No. Let's try the next one. This
But
is pi.
oh, okay, sure. Oh, sorry.
E I pi.
That's cosine pi plus I
That's
sine
no,
pi.
pi is 180. So you swap it. I think it's 1 again. No, wait, no, it's -1.
Hold on, wait, what?
Because 180 pi is -1 and
Right.
sine is 0.
Hold on, that's just basically
Yeah, like what I
yeah.
said, it's -1.
Wait,
Okay.
please don't tell me there's 2 pi next.
Another
I thought
formula
it's
comes from
360.
this,
It's
is that
0.
if we add 1 to both sides,
Mhm.
I think 360 pi and like 360 theta and 0 theta are the same damn
Can
thing.
you scroll up a little? Like,
Wait, so this is like a derelict of calculus, is that right?
Yeah, I think it's either calculus or pre-calculus.
This is like a derelict of it, like some.
okay, that's correct. Okay, next one, E theta is 3 pi over 2.
That's cosine pi over 2 plus I sine pi over 2.
Teacher,
Which,
on the previous one, why is the cosine of pi -1?
okay, so what is cosine pi? So what angle is pi, Kira?
The theta.
Draw this. So this is pi over 2,
Yeah.
and this
That's like
is pi.
270 degrees.
So pi is 180. Oh.
Wait, then that's
Yes.
negative I.
Oh, okay.
This thing's negative
3
I.
pi divided by 2 is just 3 times 360 divided by 2.
Well, now that's actually just technically
That's
270 degrees.
270. So sine is negative, cosine is positive.
Wait,
Okay.
that's negative
So
one.
Negative sine for this case.
I mean, hold on, negative I think.
this
No,
is
that's
3 pi over
270
2.
degrees, son.
So it's over there. X is 0, Y is -1.
Yeah, that's negative I think.
Well, I think both are negative. Because
Okay,
it's
last one. Theta
Oh, I
is
have
2
to
pi.
next.
yeah, wait, no, that's negative sine. That's
EI 2 pi.
EI.
Okay.
360, that's the same as 0, right?
Well, technically,
Cosine.
just
So I think it's just 1 again.
yeah. It's like a full circle or something.
It's like a
Okay.
full circle.
Okay, now you see, we start at 0. We get 1. Now we end at 2 pi is still 1. Now let me ask you, what if I go another circle, EI 4 pi? What is this? Again, this will be cosine 4 pi I sine 4 pi. But sine and cosine, they are both periodic function. Cosine 0, sine 0 is also 1. So no matter what this integer is, it's always 1.
Yes. Yes, sir.
So this is the Euler formula. So the problem you may
Wait,
ask,
teacher,
where
instance
does
what-
this formula came from? How does Euler find this formula?
Is that
It's not
calculus?
from nothing, but
Wait, scroll
because
down, please, 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 please.
a
please.
few years earlier, we have a slightly simpler formula called the movie.
Scroll down, please. More down.
Oh.
Thank you. No, up.
Wait,
No.
what?
I need the notes after the circle box thing.
Oh. Wait, oh.
Teacher.
I think he's doing something. Dean Live? Oh. Wait, so we're verifying the other formula. Right.
Teacher, can you scroll up a bit?
Hold on. I think he's writing down the previous formula to be proved.
More up.
I think he's done writing.
Oh, thank you.
Okay, so this formula is in 1730.
Were
And
mathematicians actually really what?
Euler's
advanced back then?
formula. So you can see Euler's formula came 18 years later after this one.
Wait, what did math still exist back then?
Okay, yes. Okay. So he found that for any theta, if we raise to the power, we don't have to do all the power, we just need to multiply the angles. So Euler can make an improvement on this formula. Euler observed this can be extended to any numbers, not just integers. So Euler's formula you can compare it with in the integer case.
Euler is old
Wait, why have I never seen this guy?
because he's dead for like 200 years.
Well, okay.
No, but like, why is Euler more famous? Shouldn't he be more famous because he came up with the original formula?
Yes, but Euler, I think,
But
verified.
Euler expanded it, so Euler is the
Euler
one.
is special.
Euler expanded and proved it. Because
Thomas Edison
So everybody forgot about
improved
the third
the light bulb instead of inventing it, and we remember him. We
well,
don't.
hey, this was like early mathematics, man.
Okay. So if we apply Euler's formula to this part, we get EI theta. If we apply Euler's formula to this part, we get EI n theta. So the morbid formula, if we admit this, it means that this power rule about a complex exponent still holds as long as this is an integer.
Okay.
EI theta n EI theta n when n is an integer. In general, you should be very careful. We cannot go any further. Let's check one case. What happens if we allow complex numbers? Okay, in this case, I'm going to consider theta is 2 pi EI 2 pi I 2 pi. Okay, what's this? If we do this first, what's EI 2 pi?
That's just basically
EI2 pi parentheses squared, right?
EI 2 pi we checked over here.
Is 1, so it's just E.
So
wait,
this will
yeah,
be,
that's just still 1.
okay, so we expect this is just 1.
Yeah.
Watch it not be 1.
Okay, okay. So now if we apply this rule, see what do we get?
Apply this rule, that's basically just square that.
Okay,
Bro,
so what's this square?
EI2 pi, so that
That's
just
negative 4 pi, I guess. That's like because I squared is -1 and 2 squared is 4, so that's pi squared, I guess.
Wow, what is this?
Okay, so we can say if we
Abomination.
apply this rule to complex powers, then we get some contradiction. If we do this first, we get 1. If we do this rule, we get this number. They are different.
Well, what's
Is
this? Is that even allowed?
so this is a very small number. It's maybe over 100 or something.
That
It's
is
very small.
100 to 0.
teacher, I
Maybe
think that
even
is
smaller than
weird.
this.
That
The
is
point
weird.
is, they are different.
If we follow one rule, it's definitely the other.
So
So
is this the
the
only time that complex
the
numbers?
rule we had over there only holds when we have integers. We cannot go too far to allow complex powers over there. Okay, so we stop here. Let me stop recording, then I will check with you.